In exercise 4a, we should now explain how stacking can be used to create a superlearner. So we will combine multiple predictions of different models that are all trained on the same data and are trained for the same tasks. And we will weigh them, or we will weigh each prediction of each model and combine those weight predictions to a super prediction. And that could be, for example, a linear combination or linear form that looks like this. So this would be our superlearner, that is the weighted sum of the predictions of all the individual models. And then we have to somehow obtain these weights. Now there are various forms on how to obtain these weights, but we will discuss now one where we will use the predictions of the models and the weights to calculate residuals and then minimize these residuals through the weights, such that our weights will be estimated, or they are the argument that minimizes the following expression. So this is just the average over following residuals So this is squared Okay, so this is, as I said, the average over all observations. And now what we do is we leave one out cross-validation, and we will use our models, the trained models, to predict the left out. So using the all data but the ith observation, so the one we left out, we will estimate our models and then calculate the prediction of the left out observation with the trained models. And then we will calculate this residual, which contains of this weighted sum of the predictions of all the models of this left out observation and the true value. And also it's quadratic, but that's not that important right now. But the thing is that we want for this one observation now to obtain this the optimal value of W, so the weights for each of the models, and we say, okay, so dependent on how this how big this error is in the end, this is how we will set the weights. Okay, so we have the predictions of all the models, and then we use different weights to see what weights will calculate the minimum of the error, and then we will do this not only for one observation, but we will do this for all the observations. So repeat this leave run out cross validation for all the observations, and then we average overall to get the final weights that minimize the individual leave run out cross validation errors on average over all observations. So this is a little bit complicated to understand because we have first this individual expression and then we average over all the observations. Because we calculate this leave one out error for all observations. And this leave one out error from the individual observation contains of the sum of the weighted model predictions. So the weights are the argument that minimize the leave one out cross-validation loss of the weighted sum over the model prediction on average over all observations. So I think this is pretty hard to grasp with this one sentence only, but if you think about the individual loss that we calculate here with the weighted predictions of the models, and then we do this for all observations and just average over them, this is how we obtain this way we can minimize, find the optimal W's by minimizing this term here in respect to W.